Symmetry. So you guys describe symmetry for me, right? What does it mean to have symmetry? Means you fold it, it's the same. What type of symmetry do we call that? What are you drawing on your papers? Lines. So what type of symmetry do you think you get when you fold your paper? What type of symmetry do you think that is? I just said it. Line symmetry, right? When you fold, or what type of rigid motion is that when we fold something? Big vocabulary words, right? What does rigid mean?
It doesn't change the shape.
Fantastic. It doesn't change the shape or the size. What transformations do we know about that are rigid? Translations, rotations, reflections. So what type of rigid motion would line symmetry be? Reflection. Good job. All right, let's get to it. So tell me, somebody describe to me where they folded their paper and got line symmetry. Okay?
Straight down the middle at some point.
Straight down the middle. Perfect. There's one. Think 7. Another one right here. In the back. I got to get these names down. That's Joseph. Joseph? Joe! Joe, right?
Yeah.
Diagonal. Thank you. That's 3. Jenny. All right. How many? How many is that? How many times did we fold it? 1, 2, 3, 4. There are 4 lines of symmetry up here. 4 lines of symmetry. All right, let's talk about a different type of symmetry. What if I didn't want to fold the paper? This is what I want you to do. I want you to take your original image, the pre-image. I want you to take your tracing paper. So I'm going to trace. Ready for me to trace? I'll trace in red. So I'm going to trace my star like you guys traced yours. Check this out. Trace my star. It's not going to be perfect. It's hard to trace. It's pressure.
Perfect.
Awesome.
Good enough.
Now, I want you to take your star, and I want you to put your pencil and hold it down in the middle, so it's got the center of rotation is in the center. And I want you to spin the star until you get the same image. I want you to spin it all the way around. Oh, I forgot to tell you something. We got to have a start point. So I'm going to put a little red mark right here for my starting point. Why would I do that? I want to know if, like, when I get back to the beginning again, right? Uh-oh. Thank you. So I'm going to take that, I'm going to group it so that I can spin, see, now I can see where it's going to, I want it to go all the way around. How many degrees is it to go all the way back to start?
360.
Excellent, 360. So tell me how many times you can turn it. Work, turn. Okay, I think I didn't say this correctly. As I'm turning this, going around to 360, there is a point where, look, it's the same, right? As I rotate it, doesn't that have symmetry? It's the same symmetry? How many times can I get symmetry?
4 times.
You're guessing 4 times?
2.
2.
3.
3.
4.
4. Right? 4 times. Can you tell me my angle of rotation? how much of an angle is it before I have symmetry? How'd you figure that out? Okay, hold on. There should be several ways you can figure this out. Talk amongst yourselves for like 1 minute about how you can figure out what the angle of rotation is. All right, somebody, raise your hand. Tell me, how did you figure it out? None of it once. Andrew, you volunteering? Come on, how'd you figure it out? What's the angle of rotation? How'd you figure that out? Oh, because it makes the right angle. Good, I like that. Anybody else figure out a different way? Let's hear it, Giovanni. Oh, quadrants. So there's 4 quadrants. I love it. Good vocabulary. Let's hear it.
So if you get back to like your original point, you have to do it like 360 degrees, but you only did it once. You divide it by 4 to get 90.
So if I take 360 and I divide it by 4, I've got 4 different vertices here, right? Couldn't I also do this? Isn't 36 times 10 360? Let's break it down anymore. How can I break down 36? 90, right? Too much. It's not too much. You can see the math. Do you see how you can see this math happening? You're not guessing. You're not putting it in a calculator and hoping you didn't hit a key wrong. You can see that, right? 4 divided by 4 is 1. All that's left over is 9 times 10. You know what 9 times 10 is, right? I break everything down. That's the way I do it. Okay, so I have more than one angle of rotation, though. I have 90. What's the next angle of rotation? 180. What's the next angle of rotation? Do I really need to say 360? I mean, that's like, I don't. Because it's all of the angles of rotation before you hit 360. Okay, 360, you're just known. If you go in 360 degrees, you're in the same spot. Thank you. Did you give me the other one too?
Yeah.
Okay, so now we have a general understanding of line rotation and, line symmetry and rotational symmetry, correct? So now let's start our lesson. We already did this. Let's talk about this. This is on page. I want you guys to tell me if you like this style better and if it helps you. I'd also like to ask you, is it beneficial for you guys to have the patty paper and doing it yourself? That rather than me just do it and show you? A lot? Okay, good. Then we'll continue doing this. I would really like almost every lesson to be able to investigate like this, hands-on, and then talk about it, rather than doing the opposite. Because this star is actually further into the lesson, and I went and I grabbed it from the book, and I copied it, and I had you guys manipulate it before we even started the lesson. I think this is going to help a lot. All right, draw the lines of symmetry, if any, on each figure and tell the total number of lines of symmetry in each figure has. This is on page 102. Okay. You tell me how many lines of symmetry does this rectangle have? 4? Tell me where they are. 1, 2. Is that a line of symmetry? Why? Do you guys remember what it's called when it doesn't land on top when you fold it? It means they don't, starts with a C. Coincide. Good job. It doesn't coincide. So this is not one of the lines of symmetry. So how many lines of symmetry do we have?
2.
2. You could fold it twice. What about this figure?
0.
None. What about this figure?
1.
Where? Diagonal, I like that word. Diagonally. One has 1. All right, let's talk about this. What do you have to know about any segment and angle in a figure to decide whether it has line symmetry? So what do you have to know about lines, segments, and angles in order for it to have line symmetry? Yeah, right? You've got to have the same measure. So segments and angles must have the same measure. So what about this one? Does this one have angles and segment measures that are the same? Okay, so let me ask that again. How does this one have segments and angles that are the same measure? Can you tell me? It would coincide. Like this side right here would coincide with this one right here, right? Don't they have the same measure? And this one right here would coincide with that one right there? And if you split that in half, they'd have the same angle, right? What's this angle? Right here. What's that angle? 45, right? Because it's a 90-degree angle, so half of it would be 45 degrees. Perfect. What type of figure has infinite numbers of lines of symmetry?
Circle.
Good. A circle. Fantastic, Joe. Discussion. A figure undergoes a rigid motion, such as a rotation. If the figure has line symmetry, does the image of the figure have line symmetry at all as well? So if you have a figure, right, and you have a rigid motion, and a figure that has line symmetry, and you perform some type of rigid motion, like a rotation, or a translation, or a reflection, would that new image also have symmetry? Why? Because why? Is it preserves size and shape? So if it preserves the same size and shape, of course it's going to, right? So, yes. Questions so far? Pretty straightforward, right? All right, let's do this one. This time we're talking about rotational symmetry. So, what are the angles of rotation for this one? So if I take and I make myself a copy of that image and I rotate it, you gotta put the little dot on it again, right? Let's rotate it. So I would go, see, I'm at 90. See my little circle guy on the side right there, and then what am I at? Hold on. Wait, I gotta start over, because I lost it. Okay, let's try this again. 90, then 180, then 270, and then we're right back to where we started. So it is 90, 180, 270. What about this one? 360, but do we count that one? No. You can't have rotational symmetry if it's 360 because it's just the same, right? So none. What about this one? Good, you guys can see that, right? If you turned upside down, it looks the same. Okay. What figure is mapped onto itself by a rotation of any angle? Joe?
A circle.
A circle! Good. Right? How many angles of rotation would a circle have if you moved it by 1 degree each time? A lot. 360. I guess you could say, right? 359 before you hit 360? Good. I don't like this question at all. I don't think it's very clear. We don't need to do this one because we already did it. But this one. Look for lines of symmetry. One line divides the figure into left and right halves. Let's do that. Right down the middle? Is there any more? What do you think? Nanny? Is there more? Yeah? Is there?
Are the angle measures where it says they're equal, is that also on the top too, where it says the 2 lines and the angle measures are equal? In their schema?
Yep. One there. One there. See it? It's kind of hard to see, huh? Did you guys understand what Alice was talking about? Check this out. See how it shows that they're the same? So if this angle is the same as this angle, then if you cut it in half after you turn it, it's also going to be a line of symmetry. Correct? Okay. Now look for rotational symmetry. Think of the figure as rotating about its center. So we've got the figure, and it's rotating. Draw it red. I love this rotational tool. It's pretty cool, huh? Yeah. Hey, it didn't give me the figure. Because it's kind of crazy, huh? Because I screwed up on one side. Okay? Let's try it again and see if it'll work. Yeah, it probably doesn't recognize the shape. It recognized the star. Yep, it doesn't recognize that. So we're just going to have to... It doesn't like it. I can still work with that. Alright, so we're going to rotate it. Uh-oh. There we go. Rotate it. It's rotating. Oh, that's horrible. Oh, my goodness.
Perfect.
Horrible.
Perfect.
All right. We get the gist of it, right? Okay. It rotates around the circle by a fraction of what? If you had a circle and I turned it around in the circle, how much of the circle would I have to turn it before it was symmetrical? 135? What?
1/3 or 1/20?
1/3. Right? Wouldn't you have to, if you cut a circle in thirds? Right? Wouldn't it be turn, turn, turn? It does look like a peace sign, huh? Just like there's 3 vertices to it. So Alex said what the angle of rotation was. Did you guys hear? How did you figure that one out, Alex?
I divided 360 by 3, 1/3.
360
By 1/3.
divided by 3. Isn't that also 3 times 12 times 10? And if I cancel 3 divided by 3 is 1, what's the angle? 120. So, how many lines of symmetry does it have? 3. And the angles of rotation are 120. Then what? What would be the next angle? What's the angle of rotation if I start here and I go all the way to here? Wouldn't you just take 120 and add another 120? Right? And if you added another 120, what would you get? 360, right where we started, right? Pretty easy, correct? Okay. Describe the type of symmetry for each figure. Draw the lines of symmetry. Name the angles of rotation, or both if the figure has both. So why don't you guys work on 6 and 7 for a couple minutes, and then I'll come back to you and see what you got. Okay, so number 6, how many lines of symmetry does it have? 1, 2, 3, 4. That's, what types of symmetry does it have? Line and rotational. What does it mean to be rotational? Yeah, rotate. You can rotate it and have symmetry too. How much would we rotate it in order for it to have symmetry? 90 and good. What about figure number 7? Does it have line symmetry? It does. Where is it? Horizontally. Good vocabulary. Horizontally. Does it have rotational symmetry? So only line? Angles of rotation? None. Good job, guys. Try the next two. 8 and 9, please. All right, what'd you guys find on this one? There's 1. Look it. Is this angle the same as this angle? 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 What about all the segments? There's 1 at each vertex, right? How do you know that? Because look at, guys, we talked about that, right? Where did we talk about that? Was it the star? Right here, guys. Segments and angles must have the same measure. So if you see something that has the same measure, that's a clue that there's going to be line symmetry there, right? Okay. So I see same measure, and I'm like, yeah, that must have symmetry there, 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 and there. Oh, I missed one. So how many are there? 5. Without doing anything else. Oh, gosh. You guys are all over my case on that, right? It's not in the right place. This is more. Okay, what types of symmetry does this have? Line and rotation. There's rotation. Yeah, each time you rotate this far, right? From here to here, then from here to, let's do it here. From here to here, right? To here to there and there. So what is my angles of rotation? Yes, sir. How much? How did you get that?
I divided 360 by 5 because the pentagon, so each time you rotate, the point lines up with each other as if it's a line. Okay.
Fantastic. Check this out, guys. 36 could be broken up to 36 times 10, right? Is 36, are there any 5s in there if I were to factor that?
No.
What if I were to factor 10? Maybe? I'm even going to break it up. 6 times 6? So 6 times 6 times 5 times 2? Cancel. What's 6 times 2? 12. What's 12 times 6? 72. What would be the next angle of rotation? 144. And the next one? 216. And the next one? Is there any more? There's one more. If you add 72 to 288, you're going to get 360. How about this one? Does this have any type of symmetry? None. 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 Nada. Nada. Zilch. Null. How are the two types of symmetry alike? How are they different? How are the two types of symmetry alike? They look the same. Say it again. They both represent symmetry. I know you have it. I know it. I know it. I can sense it. They both what? Line symmetry you hold, right? And rotational symmetry you rotate. But what's happening with both of those symmetries? They both preserve what? Shape and size. What kind of motion do we call that? They're both rigid. They're both rigid motions. What's the difference between them? Rigid motions, but what? One is rotating, and the other? What is it doing? Reflecting. Good job. Aren't those both rigid motions? But different. And this one's kind of, how do you determine whether a figure has line symmetry or rotational? You reflect it or you rotate it, right? Fantastic. Get your homework done, guys. Good job today.